just did it perfectly, so you went out of frame.
Pardon me. Now, you have a wave speed lab to finish. It's going to be epic like the sax guy. This is your homework. We're not doing it again in class. You want to stay home today? Oh, I don't want to go to school today. Why not? Oh, too many snow days and I need another Friday. Guess what? School is happening. You're going to figure out wave speed from the lab you just did. You had a bunch of data. Your data came from these tables. Then you did some calculations for the 15-foot scenario with the 1 bump, 2 bump, 3 bump. And you also did it for the 22-foot scenario.
You did?
Yes, you did.
Oh.
Yes, you did. You found the frequencies, you found the wavelengths, and now we're at the point of finding the wave speed based on this equation that I told you a couple weeks ago. Speed is frequency times wavelength. So, we have 6 different speeds you need to calculate. And so we could even label them up like this. You need to find the speed when you had the 15 tile with 1 hump, 15 tile with 2 humps, 15 tile with 3 humps, and you need to do the same thing for the 22. 1 hump, 2 humps, 3 humps. Fortunately, this is the easiest part of the lab. So, using this equation, you'll find the speed by taking the frequency that you determined for the 15 tile 1 hump situation and multiplying by the wavelength you determined for the 15 tile 1 hump situation. Once you do that, you will get a wave speed. So, let's go and look. We have these numbers already done. Here we go. So we found the wavelength, for example, for the 15 tile 1 hump. Everyone should have 30 feet per cycle. That was the wavelength. Now the frequency for the 15 hump 1 tile was your own. Most people got a frequency somewhere around 1 cycle per second.
No.
For 15-1?
Oh, for frequency? Oh, yeah.
Yeah, for frequency. So the wavelength was 30, and the frequency was around 1.
Wait, do we have to do your numbers or ours?
Your numbers. Do your own numbers. Around 1. And so, everyone here for wavelength will have 30 feet per cycle. That was the same for everyone. But I'll change the color. You will have your own blue. It's going to be somewhere around 1 cycle per second. Your own number, though. This will be your number. For example, we have a couple of people here. Maybe you were in their group. John, what was your number for the frequency?
So ours was 1.02.
1.02. Christian, what was yours?
For what?
The frequency for the 15. 15-1.
0.95.
0.95. Anybody have a different number? Probably, but most people were around the 1. So that's where your number goes. Your number will probably vary somewhat from 1. Roughly speaking, when you multiply these two, you're going to get an answer near 1 times 30? Near 30. It's going to be somewhere around, I'll put that's an approximate, 30 feet per second.
Wait, is that 30 feet? Is that go for the 22 as well?
30 feet per second. Now, you might get a number a little above or a little below, but somewhere around there. 15.2 and 15.3, when you plug this in, beware, you're going to have, again, your number goes into this slot for the frequency, and everyone will have the same wavelength, but the wavelength is not 30. You go and look and see what it is. What is the wavelength for the 15.2? That's right, the wavelength over here was 15 feet per cycle. And you put in your own number and you come up with a speed.
Is it 15 because there's 2 humps?
That's right.
Like half.
Right, because 2 humps actually means 1 full wave.
So would 15.3 be 10?
15.3?
Yeah.
Yeah.
How do you do it for the 20?
Now the same thing over here, so then you'll also have to do this for the 15.3. can pause the video and finish your calculations. Welcome back. Bless you. Bless you. When you're solving the 22 case, you again, at all points, this is V equals frequency times wavelength. The frequency, you will pull off your numbers. This will be yours, whatever it is. Everyone will have the same wavelength here, though. What is the wavelength for the one hump 22-foot case?
What's that?
44.
Yes. The wavelength for this one will be 44 feet per cycle. Be very careful, it is not 30 again.
Is that because for the 30 we double the 15 and what, 44 is double 22?
That's right.
Why is it double?
It's not that it's double. It's that when you have one bump, that's what we call half of a wave. So if half of a wave took up 15 tiles or 15
Full
feet,
wave would be
full wave is going to take up that amount again. Here, 2 humps is actually 1 full wave. 3 is 1.5.
Dunzo.
So once you have this all calculated, there's a couple of questions you're going to have to do as well. I'm just curious, by the way, what were your frequencies for the 22-1? 1.1? 1.1? So you may get a number somewhere around 1.1. Take that symbol out. Around 1.1, this is cycles per second. And so your actual wave speed over here came out to somewhere around, this is going to be your number again. What are people getting? About 48? What'd you get for your wave speed? Christian?
For 22.1?
22.1, what'd you get for your wave speed?
48.4.
Alright, so somewhere around 48 feet per second. Now there is, once you have all 3 done on both sides, Saul!
Yes.
Wake up, man. Once you have all 3 done on both sides, what you're going to do is come down here and write a little comment. How do the wave speeds for the 15 situation, 15.1, 15.2, 15.3, how do they compare to each other? Are they pretty close to each other? Are they one's much faster than the others? Whatever it is, does it get faster with the number of humps? So there are 2 questions to answer down here. You call this question 1. How do the 15-foot situations, you just answered, compare, and you're comparing here for the speeds. And then question 2 over here, same type thing. How do the 22-foot situations compare? Again, we're talking about speed. So you're going to look at the speeds for these 3 and then for those 3 and make a comparison. Loosely speaking, did you notice a comparison? You make one quickly?
I mean, 15.1 and 15.2 are the same exact speed for me.
And 15.3, how far away was it?
2,
Not too much?
3, not at all.
Okay, so they're pretty similar. Were your 22s similar?
Yeah, but they had a wider range.
Okay. So you make a little commentary on those 2 things. We are actually going to then loop this back next week and compare this to the lab that you guys already did with the pluck. All right?
We're done with this?
You are done with this for now. If you're done, hand it in.
Give a quick ha-ha on the camera. Ha-ha.
Ha ha. Yeah, you gotta do this on your own.
Sax guy.
Oh yeah.
It's the outro.
That's the outro. That's right.